So now we're going to take all of these micro, either molded or micro machined components and put them together with other dust spec size parts. And our preferred method for joining those parts together is totally avoiding it altogether. In other words, we may try to combine geometries of two parts to within a mold itself to create that kind of an assembly within the mold. But we can't always do that. So that's our preferred method, is to avoid that, because what we don't want to do is pick up literally a dust spec size part, position it to another dust spec size part. It's very costly to be able to position those accurately and certainly hang on to those parts accurately enough in a fashion where you can make millions and millions of them. So other joining methods that we use with dust spec size parts are ultrasonic or laser welding, epoxy, which is still used a lot today, even in micro-molded components. In-mold assembly, which is what I've just talked about, was actually creating a mold, creating the rotating mold to build one material, rotate the mold, shoot in another material, which would be like a two-shot injection molding process. And then chemical methods as well. So this particular assembly shows two lasers that would take maybe a micro-molded component, a machined component, then it gets placed together maybe with a silicone. The silicone actually encapsulates something. It gets lasered through a series of positions and then gets outlaid to the next tray, as an example of a micro-assembly. This is a different assembly that we used for a membrane system with a molded part. So this is a rotary fashion that took that membrane, cut it, placed it in place, ultrasonically welded, did a pressure decay test in a less than 2-second cycle all the way through this process. So the less we can handle it, the better. We can't always avoid that.